Welcome to Tomorrow Unveiled Curious Minds. This week, we're rocketing into a topic that really feels like science fiction is, well, turning into fact right before our eyes. We're talking about the incredible flurry of space technology breakthroughs from just the last week of August 2025.
It's quite a week.
Absolutely. Our dedicated research team pulled together a whole stack of sources, articles, papers, reports, and our mission today is, well, pretty clear. We want to distill the most important knowledge, the key insights from everything we've gathered on Beyond Earth, this week in space.
And what really stands out when you look across all this information is the convergence.
Convergence, how so?
Well, you see all these different technologies, propulsion, sure, but also manufacturing in space, advanced navigation, things that were theoretical, they're all starting to click together.
Becoming practical, operational realities.
Exactly. It's not just about, getting to space anymore. It's about building, working, maybe even living there eventually. It's a fundamental shift.
A reshaping of what we can do beyond Earth.
Precisely. So, as we connect the dots for you today, you'll see how these pieces are really forming a foundation for a sustained human presence out there.
Okay, let's unpack this then. And I guess we have to start with the biggest headline. SpaceX's Starship Flight 10.
That's the one, August 27th. After several previous test flights, this was different.
Yeah, our research team highlighted this. It wasn't just another test. It was a monumental success on, multiple levels.
Right. First off, payload deployment.
Oh, yeah. Get this for the first time. Starship actually deployed satellites. 8 dummy Starlinks, sure, but deployed them.
And the mechanism, this sort of Pez dispenser-like system. It sounds funny, but it's actually a really clever solution.
And vital, right, for deploying future mega-constellations efficiently.
Absolutely critical. Think about deploying hundreds, maybe thousands of satellites. You need something like this. It validates that core capability.
Okay, so deployment checked off. What else made Flight 10 so significant?
The engine relight in space.
Ah, the Raptor relight? And that's only the second time they've done that with the upper stage.
That's right, and it's absolutely crucial. You need that capability for complex orbital maneuvers, changing orbits, heading to the moon or Mars.
And for deorbiting properly, too, I imagine, to avoid creating more space junk.
Exactly. Precise control for coming back down. So relight capability is another huge check mark.
Okay, impressive stuff. But, pushing the boundaries like this,
yeah,
it rarely goes perfectly smoothly. What about re-entry? The heat shield.
Ah, yes. Well, the data shows there was what they called significant thermal distress, even some partial burn-through on the aft flaps.
Wow. How hot did it get?
Temperatures apparently hit around 2,600 degrees Fahrenheit. So yeah, intense.
But did it survive? Did it maintain control?
That's the kicker, yes. Despite the damage, it stayed stable. And this is, classic SpaceX. It wasn't really a failure in their eyes.
It's data. Invaluable data.
Precisely. Their whole iterative approach is built on finding these limits, learning from the heat, literally, and then improving the design rapidly.
Okay, so heat shield data gathered. What about the landings? Both stages, correct?
Correct. Both the Super Heavy booster and the Starship upper stage performed complex landing burn tests.
Any highlights there?
Well, the booster successfully handled an engine-out scenario during its burn, shows redundancy, and both stages achieved a soft splashdown.
So putting it all together, what's the big picture takeaway from Flight 10?
If you zoom out, this flight is a massive de-risking step. It directly supports NASA's timeline for Artemis III, the lunar landing plan for 2027.
Because Starship is the lander for Artemis III.
Exactly, and it also pushes SpaceX's own Mars colonization goals forward significantly. It's moving from can it fly to how do we operate this thing reliably for real missions?
Okay, so Starship's moving into an operational phase almost, but SpaceX also has its workhorse, the Falcon 9. Any news there?
Oh, absolutely. While Starship got the spotlight, Falcon 9 quietly set another record. Booster B1067, get this, completed his 30th successful launch and landing.
30, on August 28th, right? Launching more Starlinks.
Yep, 28 more Starlinks. But that number 30, it's not just a number.
It signifies maturity, doesn't it? Industrialized reusability.
That's exactly the term. It proves that reusable rocket technology isn't experimental anymore. It's an operational, industrialized process.
And that directly translates to lower launch costs and a much faster launch cadence.
Fundamentally, it makes space access cheaper, faster, more routine. It's a true game changer for the entire industry.
But it's not just SpaceX driving this launch revolution, is it? The landscape seems to be getting more diverse.
Definitely. And that's really healthy for the ecosystem.
Like rocketlab, They just opened a new launch site.
Yeah, big news from them. On August 28th, they officially opened Launch Complex 3 at Wallops Island, Virginia. This is specifically for their new reusable Neutron rocket.
Neutron is their bigger rocket, aiming for the medium lift market, right?
Yeah.
Competing more directly with Falcon 9.
Exactly. So this adds significant U.S. launch capacity, crucial redundancy, and really puts pressure on that medium lift segment.
And across the Atlantic, Europe's making moves too.
Very much so. Our research noted that the German provider, Iser Aerospace, secured some pretty landmark contracts with ESA, the European Space Agency.
Okay, so that signals Europe is serious about building its own commercial launch capability, sovereign access.
Absolutely. They want their own independent, commercially viable way to get to space. So you've got SpaceX pushing boundaries, established players like ULA, newcomers like rocketlab stepping up, and now a stronger European push.
It leads to a big question, doesn't it? What does this increasingly multipolar launch market actually mean for, global space exploration and business?
It's a great question. Generally, more competition is good, right? Drives innovation, pushes costs down for everyone needing a ride to orbit.
Seems logical, but could it also create friction? Like coordination issues, different standards, maybe even regulatory headaches if everyone's doing their own thing?
That's the potential downside, you're right. The challenge will be harmonization, agreeing on orbital rules of the road, managing traffic, standardizing certain interfaces. It'll require cooperation, even amidst competition.
A balancing act, then. Fostering innovation without creating chaos.
Exactly. It's crucial for a long-term sustainability up there.
Okay, so that covers getting to space. But like you said earlier, it's also about what we do in space. And the ISS seems central to that right now.
It really is. It's transforming from just a laboratory into, well, a proving ground, an incubator for the future space economy.
And the recent SpaceX cargo mission, CRS-33, delivered some key pieces for that. Launched August 24th.
Correct. One really interesting piece of hardware was the Dragon Reboost Kit.
Reboost kit.
Yeah.
So using the Dragon cargo craft to actually push the station higher.
Precisely. This kit has its own independent engines, and it provides significantly more reboost capability, about 1.5 times, than a Russian Progress vehicle, which has traditionally done a lot of that work.
So the significance there is redundancy. U.S. operational independence for station keeping.
That's a big part of it. Less reliance on international partners for that critical function, but it's also a tech demo.
Demonstrating technology for
Yeah.
what comes next.
For the future U.S. deorbit vehicle, which will eventually be needed to safely bring the ISS down. So Dragon goes from just delivering cargo to actively maintaining the station and testing tech for its eventual retirement.
That's a pretty smart evolution for Dragon. Blurring the lines between visiting vehicle and station system.
It really is. And CRS-33 carried something else, potentially even more forward-looking.
Right, the orbital data center prototype from Axiom Space and Red Hat.
Yes, testing terrestrial-grade edge computing hardware in space.
Edge computing. So processing data right where it's generated in orbit instead of sending it all back to Earth first.
Exactly. Think about the massive data sets generated by Earth observation or complex simulations or even supervising in-space manufacturing. Downlinking all that data is a huge bottleneck.
Limited bandwidth.
Right. So if you can do the heavy processing up there, close to the source, using AI, machine learning, it unlocks incredible potential. Real-time analysis, autonomous operations.
That sounds like a foundational piece for a real EO economy, turning LEO from just research into like an industrial park in the sky.
That's the vision. Robust in-space computing is a must-have for that.
And speaking of industry in the sky, CRS-33 also had more 3D printing experiments.
It did, including bioprinting, medical implants, and also printing metal parts in microgravity.
Towards autonomous manufacturing.
Yeah.
Being able to make what you need when you need it, whether you're on the ISS or eventually the moon or Mars.
That's the goal. Printing tools on demand, replacement parts, even medical devices. It dramatically changes the logistics and possibilities for long-duration missions.
It's fascinating how the ISS, even as it nears its end of life, is being used so strategically.
Absolutely. It's flight qualifying. These essential utilities, the reboost, the data processing, the manufacturing techniques that the next generation of commercial space stations will absolutely need. It lowers the barrier to entry for them.
Really paving the way. Okay, for our listeners on YouTube, if you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and definitely turn on notifications so you never miss an update on the future unfolding. Now, with all this activity, more launches, more satellites, future stations, the issue of space traffic, and especially debris, becomes even more critical, right?
Paramount. Absolutely paramount. And Europe is making a significant move here.
This is the new ESA station.
Yes, the European Space Agency just announced the commissioning of the Izania 2 station in Tenerife.
Okay, Izania 2. Working with Izania 1, which already exists.
Right. Together, they'll be testing advanced laser-based technology for tracking space debris.
Laser ranging. How accurate is that compared to, say, traditional radar?
Significantly more accurate. We're talking centimeter-level precision.
Centimeters.
Yeah.
That's incredible detail for tracking small, fast-moving objects.
It is, and it leads to a really fascinating long-term concept they're exploring.
Which is?
It's codenamed OMLET. Stands for Orbital Momentum Transfer Using Lasers.
Okay, using lasers to move debris.
Gently nudge it, exactly. The idea is to use ground-based lasers not to destroy debris, but to impart just enough momentum photon pressure to slightly alter its orbit and prevent a potential collision way ahead of time.
So shifting from reactive maneuvering, dodging junk, to proactively clearing the path.
That's the paradigm shift. Proactive debris mitigation.
Wow. What are the implications if that technology proves viable?
It could be essential for the future. With mega constellations adding tens of thousands of satellites, the collision risk grows exponentially. Laser momentum transfer could be key to maintaining the long-term economic viability and sustainability of, well, everything we want to do in ILIO.
It becomes a fundamental safety service, which raises another question.
Who provides it? Who manages these orbital path clearing services? Will it be government agencies, commercial providers? That's still an open question.
Definitely something to watch. Now, amidst all these breakthroughs, the week also served up reminders that space is still hard, right? Challenges remain.
Absolutely. Successes often come hand in hand with learning opportunities, let's say.
Like with Starship Flight 10. Despite the overall success, there was that damage, the explosion reported in the engine bay, the plasma burned through on the flaps we mentioned.
Right. And it just underscores the immense engineering challenges still involved in achieving truly rapid aircraft-like reusability. But again, for SpaceX, finding these issues is part of the process. Fail fast, learn faster, iterate.
It's baked into their philosophy.
It seems to be.
And it wasn't just in-flight issues. Ground systems caused problems too.
Yeah, we saw multiple launch scrubs reported this week for Starship. Also, for Blue Origin's New Glenn, I believe often traced back to ground support equipment or infrastructure.
So even as the rockets get more advanced, the complex web of systems on the ground needed to launch them frequently and reliably. That remains a critical bottleneck.
It's a huge piece of the puzzle. High launch cadence requires incredibly reliable ground operations, and that's still a work in progress across the industry.
It grounds us, I suppose, in the engineering realities. It's not just the shiny rocket, it's everything supporting it.
Exactly. But the overall direction, the trajectory, is undeniable.
Which is?
A rapid maturation across the board. Capabilities are solidifying that will speed up our path back to the moon with Artemis, eventually to Mars, foster that commercial LEO economy we talked about, and really drive this vibrant, competitive launch market.
So, wrapping this all up, what's the big takeaway? The final week of August 2025 feels like a real turning point.
I think inflection point is the right term. You're seeing capabilities move decisively from theory and testing into operational reality. Reusable rockets becoming routine, orbital data centers being deployed, advanced debris tracking coming online.
It's happening across multiple fronts simultaneously.
Right. And it's that convergence again. High precision navigation, autonomous manufacturing in space, cheap reusable transport, advanced communications. They all feed into each other.
Enabling both the economics and the technical feasibility of doing much more, much further from Earth on a sustained basis.
Exactly. It's a profound shift from just experimental exploration to actual operational utilization of space, building a real economy out there.
Okay, this week's deep dive really makes it clear. The foundations for a true beyond Earth future are being laid, like right now, rapidly. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It honestly helps us reach new listeners curious about the future, and we genuinely love hearing your thoughts. Whether you're watching on YouTube or listening on your favorite podcast app, drop a comment and let us know what you think about this incredible week of space technology breakthroughs. And finally, for you, our listener, the provocative thought we want to leave you with today is this. As humanity keeps expanding its reach, its capabilities beyond Earth, how does this accelerating shift start to redefine what it even means to be a global or maybe even multiplanetary civilization?
And how will these developments ripple back to shape life here on Earth, what entirely new opportunities or maybe unforeseen challenges might emerge in your lifetime because of all this.
Lots to think about. Keep exploring, keep questioning, and join us next time for another deep dive here on Tomorrow Unveiled.